Hi guys, welcome to the another session of trigonometry. Now, on our previous session, we have discussed on trigonometric identities, right? So how we derive the identities and what are the steps and what are the different identities we have. So we have seen all those things. But in today's session, we'll be discussing the problems related to a trigonometric identities. Okay. Now, the very first type of problem, what we're going to look is now express the trigonometric ratios sin A, secant A, and tan A in terms of tan A in terms of cot A. So we need to express sin A, secant A, tan A in terms of cot A. Okay, so hope you have understood the question. Now we need to write sin A in terms of cot A, secant A in terms of cot A, and tan A in terms of cot A. Okay, now first we shall look into sin A. Okay, now we all know the identity, that is sin square theta plus cos square theta is equals to 1, right? So instead of A, I've just taken it as theta. You can just write it as A as well, so that doesn't matter. Now divide both the sides by sin square theta. Now I'll be dividing both the sides by sin square theta. Now this is sin square theta by sin square theta plus cos square theta by sin square theta is equals to 1 by sin square theta. This gets cancels out. So 1 plus cot square theta is nothing but 1 by sin square theta. You might tell 1 by sin square is nothing but cosecant square, but please make sure you're not taking it. Okay, or else you can just directly start up with 1 plus cot square theta is equals to cosecant square theta, and where cosecant square theta is nothing but 1 by sin square theta, where you can do it in that way or else even in this way as well. So whichever you feel comfortable and whichever you feel very easy to do it, you can go ahead and do it. Instead, by doing that method, you will be solving some time because you'll not be doing this step. Okay, so even you can do it in that form as well. 1 plus cot square theta is nothing but cosecant square theta, and cosecant is nothing but 1 by sine. So 1 plus cot square theta is equals to 1 by sine square theta. Okay, now sine square theta is nothing but 1 by 1 plus cot square theta, right? So this is what the sine square theta is. Now sine theta is nothing but 1 by square root of 1 plus cot square theta, right? Because this square goes here and becomes a square root. Anyhow, the square root of 1 is nothing but 1. So your denominator, that is square root of 1 plus cot square theta. Okay, now look here. Sine theta is written in the form of cot theta. Easy. So this is how you need to write, guys. Now we have done with the sine A. Now what we need to do, the second one, which is nothing but what is the second part of the question is secant A, or secant A in terms of cot A. Now what is, now we have an identity, that is 1 plus tan square A is equals to secant square A. We all know this, correct? And I will divide by tan square A on both sides. Now dividing this gives us 1 by tan square A. This is tan square A by tan square A. Tan square A by tan square A is equals to secant square A by tan square A. Correct? Now this gets cancels out. Now what is 1 by tan square A is nothing but cot square A, and this is nothing but plus 1 is equals to secant square A by tan square A. So we got this equation. Now we got the equation as 1 plus cot square A is equals to secant square A by tan square A. And once again 1 by tan square is nothing but cot square A, right? So I can write it as secant square A into cot square A, right? Now this secant square A is nothing but 1 plus cot square A by cot square A. Now what do I require? It is only a secant, correct? Now I'll just keep the secant A here and I'll just shift this. So whole square root of 1 plus cot square A by cot square A, and what I'll be left out with is 1 plus cot square A by cot A, right? So this is my required answer. Okay, easy, simple. I think it looks very simple, right? Now what is the third part of the question? It is tan A. Now which identity we're gonna use? Now if you have thought of any identity to use in this sum, absolutely no required, guys. Now tan A is expressed in terms of cot A. How? Tan A is equals to 1 by cot A. That's it, nah? Why do you require any identity for this? So if you have thought tan A is nothing but 1 by cot A, you're good. Excellent. But if you're thinking of any identities, so that means you're overthinking. So just don't do that. Just stick on to the basics. Okay? The sums looks very simple, the problem. Okay? So this is one type of the problem what you'll be getting. Now, moving on to the next type. Now suppose there is a sum, that is sine square 63 plus sine square 27 by cos square 17 plus cos square 73. Now we understood the sum, right? Sine square 63 plus sine square 27 whole divided by cos square 17 plus cos square 73. Now what is the value of this? Now we all know in complementary angles we have studied it, right? Now what is this? Sine square 90 minus 63, correct? Can I write 27 as 90 minus 63? Correct? Whole divided by cos square 17 plus cos square. Can I write 73 as 90 minus 17? Come on, go back to the complementary angles now. Look, this is a mixture of everything, guys. Right? Now what is sine 90 minus theta? It is cos theta. Now please remember all those things. Sine square 63 plus cos square 63. Correct? by cos square 17 plus sine square 17. You got this? Look, here is the application of complementary angles. Sine square 90 sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. But since we have squares, we are just adding it. Now, what is sine square theta plus cos square theta? 1. Once again, sine square theta plus cos square theta, 1. 1 divided by 1 is nothing but 1. So, the value of sine square 63 plus sine square 27 divided by cos square 17 plus cos square 73 is nothing but 1. Easy. Look, the sums looks very simple, guys. Right? Now, the next question. Now, find 9 secant square a minus 9 tan square a. What is the value of this? Okay. Now, I shall just write it as 9 secant square a minus. Now, what is tan square, guys? 9 1 plus tan square theta is equals to secant square theta. Correct? You remember this? Identity 1 plus tan square theta is nothing but secant square theta. So tan square theta is nothing but secant square theta minus 1. You need to just write the same thing, which is nothing but secant square theta minus 1. Okay? You need to just remember all these things, guys. The sum looks very simple. Now, 9 secant square a minus 9 secant square a plus minus into minus is plus, and minus 9 into minus 1 is plus 9. This minus gets cancels out. What do you left out with? It is 9. So what is the value of 9 secant square minus 9 tan square a is nothing but 9. Look, everything looks very, very, very simple if you know the basics very well. Now let's do one more sum. Now 1 plus tan square a by 1 plus cot square a. Okay, so the sum is very simple. 1 plus tan square a by 1 plus cot square a. Now what is the value of this? Now apply the rule, right? We need to just apply the identity. What is 1 plus tan square theta? Secant square theta. What is 1 plus cot square theta? Is cosecant square theta. Simple. Just keep it simple, guys. You need to just keep the things really simple. Now what is secant square? 1 by cos square theta. And what is cosecant square is nothing but 1 by sine square theta. Now denominator of the denominator goes to numerator. So sine square theta by cos square theta, which is nothing but tan square theta. Look, the sums are really, really, really easy. Okay, there are some higher level problems which we'll be discussing very shortly, but make sure you learn all these basic sums. Okay, now moving on to the